Hey, Mr. Landon here. We're gonna learn about the unit circle today. It is absolutely amazing, and what I wanted to do is I want to draw a unit circle here and show you all of the different things about it. But let me ask, May, do you want to draw it with me?
No.
Oh, okay. Well, you do. Okay. Let's go over here then. Okay, here's that. So what we're gonna do is maybe I should draw it, but
Can I?
well, I guess. But just make sure you draw like a perfect circle. No, bigger than. You just gotta. No, Grace, wait. Draw a bigger circle. No, stop. Okay. So Grace got pen on the wall.
No, I didn't.
So, can you see it? Oh no. So hopefully we'll get that out before I get in trouble for that. Okay, so Naomi told me that if I put dry erase marker on it, it should come off. So I am going to attempt to get that off with the dry erase marker. Make sure that we're good there. All right. And then she says if you go, it should just come off. Nay?
Are you sure that was dry erase?
Oh, this is wet erase.
Yeah, you're gonna get it dry.
All right, so I got some dry erase on this tissue. What? This is gonna get on the couch. Okay, let's move the couch. This is, what the heck?
Did you use this?
Yes, it's a dry erase. It has the clicker. Okay, so Caleb tells me that if you take real Sharpie and you put it over, the chemicals will counteract. And so I'm gonna go like that, and that kind of where it's kind of working. So if I go like that, no, it's not. Oh, great. That's permanent. I need something to cover
I
this
got
up.
Band-Aids.
A Band-Aid? Okay, hold on. Oh, Grace! Oh, that's permanent. Great. Okay, so I think I fixed it. It's not really noticeable anymore because I got the Band-Aids on it. And then this one over here, I'm going to be putting up a shelf, and so I don't think anyone will notice. I'll be putting up it'll be like a shelf. It'll be like, well, I mean now it'd be like right there would be the shelf, and then I'll probably have like a plant or something maybe like up here, and then like that direction here, like we'll have, yeah, right about there. I'll put a well, that's like a 45-degree triangle and a 45-degree triangle and a 90 right there. Yeah. Okay, so I decided to fix it by putting like a triangle, like I put a shape over it so it wouldn't be as noticeable. And then I figured I may as well just continue on. And so like here, this is like a 45, 90 triangle, and then the hypotenuse, that's the longest side's always 1, right? But see over here, this is the 30, 60, 90 triangle. The angle's a little lower here, but the hypotenuse is still always 1. And up here, this is actually the same 30, 60, 90 triangle. It's just flipped over from this one. It's the same one, it's just flipped, because now it's a 60, 30, 90. And notice the hypotenuse is always 1. And what I can do is I can take this triangle right here, and if I just picked it up, right, off of the wall, and I brought it over, and I dropped it off right here, it would become this blue triangle right here, 30, 60, 90 triangle, where the height of it is 1/2, right? Just like the height over here was 1/2, and then the hypotenuse is 1, and the reason it's 1 is because it's a unit circle. 1 unit would be the radius here, so if I brought that up, then that would be 1 unit. The whole length of the hypotenuse would be 1 unit. And so what I have here is that if the base of this is going over the square root of 3, right to here, if I go square root of 3 over 2 to get to here, and then I go up 1/2, then this coordinate is the square root of 3 over 2, comma, 1/2. I went over the square root of 3 over 2, I went up 1/2 because it's a special triangle. And then this one in black, that's the middle one. It's the 45-degree triangle right here. The 45-degree triangle is root 2 over 2, root 2 over 2. You can use the Pythagorean theorem to prove that, by the way. A squared plus b squared equals c squared. But if I picked this one up and I went right over here to there, it would drop off into the black triangle as a 45-degree triangle there. And what would happen is if I went over the square root of 2 over 2 and up the square root of 2 over 2, I'd be located right there. So this is the square root of 2 over 2. That's a terrible 2. Square root of 2 over 2. All right, and then my last triangle is, of course, the 60, 30, 90 triangle, which is, again, the hypotenuse of 1, but the height is, it's flip-flopped, it's opposite, right? If I pick this up and I drop it over here, it becomes the purple triangle, and the purple triangle here is a 60 degree, because it's my 60 degree triangle here, this is 60 degrees, and then that height there is the square root of 3 over 2, and the base right here would be 1/2, so 1/2 square root of 3 over 2, because, of course, right here, 1/2 square root of 3 over 2, which means that the coordinate up here would be 1/2, 1/2, and then the square root of 3, oh, that's bad, over 2. Oh, look at that, that's hard to see. Okay, guys, it's getting even better because I was like, I hadn't quite finished, and now it'll actually look good. And so what I'm going to do is I'm taking this blue triangle right here. Oh, this is my masterpiece! This blue triangle right here, the 30, 60, 90 triangle that started off over here, right? The 30, 60, 90 triangle that started off over here, square root of 3, that distance over 2, and then 1/2, and I brought it over here, that blue triangle right here. Now, if I were to just flip that over, right? Just flip the blue triangle over, then wouldn't I have to go, instead of going up 1/2, I'd be going down 1/2, right? I'd still be going over the square root of 3 over 2, but I'd be heading down 1/2. That's why this x-coordinate is the square root of 3 over 2 going to the right, and my y-coordinate is down. It's negative 1/2. But I could take this whole triangle and flip it over here! I just knocked something off my son's wall in his room. And then what happens is that this distance is the square root of 3 over 2, but it's in the negative direction. And then the distance goes down negative 1/2. So that's where that coordinate comes from. If I flip it up this direction, then it's still 30, 60, 90 degree triangle. But it's a negative square root of 3 over 2 is the x direction, and then up 1/2 is the y direction. And so I can do that with my blue triangle, flipping them and flipping them, but I could do that with my 45, 45 degree triangle too. And I could do it with my 60, 30 degree triangle too. So guess what? I'm gonna pause right now, and I'm gonna fill this thing in, and my masterpiece is gonna look wonderful! Okay, so I got the circle written down. I gotta show you how it is. So we talked about the blue being flipped over, but I could flip the black one over too, and if this was square root of 2 over 2 and square root of 2 over 2 to get to that one, then when I flip it over, I gotta go really fast because my wife's gonna be coming home in just a second. When I flip it over, then I'm gonna end up down here where I go over the square root of 2 over 2 and then down the square root of 2 over 2 at that coordinate right there. And then
where are the radians?
I haven't got the radians on here yet. I'll get them right now. Hurry! So my wife absolutely loves this mural. She just wants to know where the radians are because you see the thing mathematically over here, when the circumference of a circle, that's the distance around the circle, like the perimeter, the circumference of a circle is 2 times pi times r. But if the radius of a unit circle, 1 unit, it goes all the way across, that's 1 unit, 1 centimeter, 1 meter, 1 whatever, 1 unit, then you plug in a 1 for the radius and you get circumference is equal to 2 pi. That means the distance around the entire circle is 2 pi. If I were to walk around that whole circle, I'd get back to the start and this would be 2 pi. I mean, I'd start at 0 here, I'd walk all the way around and I'd come back at 2 pi. If that's the case, then halfway around the circle would be half of the 2 pi. If you cut 2 pi in half, divided by 2, you would just get straight up pi. That's 180 degrees. This is the same thing as pi. And then if you were to go half of that, then this would be pi over 2, which of course is a straight up 90 degree angle. So this is 90 degrees up here. And if you continue to go down, this ends up being 3 pi all over 2, which is 270 degrees, right? Because if this is 30 degree angle, and that's a 45 degree angle, that's a 60 degree angle, then that's 90 degrees, but that's the same thing as pi over 2, and 180 is the same thing as pi, right? And so I can get all these filled in for my wife, because she really wants those radians. I gotta go quickly. So I got it all fixed up with the radians now, because my wife wanted the radians, and I got them up here, you can see. So what we can do is, like the pi over 6 radians, what I can do is if I have the entire 2 pi, right, and I just want this section of it, right, the 30 degree angle right there is represented by pi over 6 radians. And then this is the 45 degree angle here, and the black triangle is represented by pi over 4 radians. And that's the same thing as your 45 degrees. Well, how do you do the conversion factor? You go over here. If you want to get degrees and turn it into radians, you take your 30 degrees and you multiply by pi over 180 because we know that pi and 180 are the same thing. Look, Right here, 180 degrees, that's a straight line. It's a straight line, and we know that's pi because it's half of a circle, half of the 2 pi. So if we multiply by pi over 180, the 30 and the 180 would cancel, and we'd be left with 6 on the bottom. Pi over 6, that's how many radians. That's how much of the radians of the circle there would be. Radians going to degrees, if I have pi over 6 radians, and I multiply it by 180 over pi, that's the conversion to go from radians to degrees. It turns into 30 degrees because the pi's would cancel, and then 180 over 6 is 30. So ultimately, we have this entire circle. It's called the unit circle. You're going to have to memorize every single degree, every single radian, every single coordinate up here, all the 30 to 45 to 60 degree angles. Everything on here has to be graded. There's like 60-something things that has to be graded when you do a pop quiz on this. But this is absolutely beautiful. I may have made a little bit of a couple marks on the wall, so I do have an extra Band-Aid that maybe we could cover. Like maybe I just get that right there. I think we're going to be doing good now. I don't know if anyone will notice. I think we're all good. Landon out!